Alright, let's look at the homework 4.4, problem number 9. Alright, so we have this function, f of x equals x plus 8 over x. Alright, so let's answer the first question. It's a line y equals x and oblique asymptote for the graph of f of x. Choose the correct answer below. Alright, so it is f of x, y equals x is an oblique asymptote because 8 over x approaches 0 as x approaches infinity, or x approaches negative infinity. So this is actually the right answer. Alright, so we have that. Alright, then next one, summarize the original one. Okay, so domain is all real numbers except for, you can see that we can't have 0, so B. Right, check that. Right, we got that. Alright, x-intercepts and y-intercept. So in order to find the x-intercept, we set that equal to 0. So let's do that. Set x plus 8 over x equal to 0. Alright. Then you see, try to find x, multiply both sides by x. So you have x squared plus 8 equal to 0. Then you realize that, okay, we can't find a solution for this guy. So there's no x-intercept. Right? How about the y-intercept? There's no y-intercept because we cannot plug in x equals 0 because that's not in the domain. So we don't have x-intercept or a y-intercept. Alright, let's check the answer. So we got that. Alright, so we want to find, let's see, horizontal asymptote and a vertical asymptote. Alright, so horizontal asymptote, if x approaches infinity, maybe I should do that. Limit as x approaches, infinity. So say positive infinity. X plus 8 over x is going to approach. Alright, so this guy definitely goes to 0, but this guy goes to positive infinity. So you can see that this is positive infinity. And if you do a negative infinity, so if you put the negative infinity, this is going to still go to 0. This is going to go to negative infinity. So you're going to get the positive or negative infinity, which means that there is no horizontal asymptotes. Right? Right? Vertical asymptote there is, because as x approaches x equals 0 is not defined. So there's a vertical asymptote because that will make this guy undefined. So x equals 0. Right? So let's type it in, and let's see, no horizontal asymptote. Let's see, no horizontal asymptote, vertical asymptote at 0. So we have that. Alright, got that. Alright, so we have to look at the first derivative. So let's take the derivative. Alright, so the derivative is going to be, so f prime of x is going to be, derivative of x is 1. Derivative of 8 over x is going to be negative 8 over x squared. Alright, we're going to set that equal to, maybe I'm going to take the common denominator, x squared, and you have x squared minus 8, right? Then we can factor out, let's see, so you have x plus square root of 8, x minus square root of 8. X squared. Alright, then we can just set that equal to 0. So we know that x equals plus or minus square root of 8. Alright, so let's do a number line. So draw a number line. And we're going to put the tick marks. So it's not defined at 0. Right? Then you have negative square root of 8. And a positive square root of 8, right? And maybe I'll put the open circle so that we know that it's not defined there. How about that? So draw that. Alright, then we're going to look at the f prime. Right, just a sign. So we can try any number less than the square root of 8. So like negative 3. Right, between that, so x equals negative 1. Between here, x equals 1. And x equals 3 or something like that. Alright, let's look at the sign. If you plug in negative 3, so that will be negative here. This is negative, so it's going to be positive here. Alright, plug in 1. 1, that's positive, that's negative, so it's going to be negative there. And if you plug in positive 1, so that's going to be positive, that's going to be negative, so it's going to be still negative there. Right? Then you have 3, so that's positive. 3 minus a positive, so it's going to be positive there. Alright. Then what you get is, so it looks like looking at the first derivative, original function is here increasing, so increasing here, decreasing, and decreasing again, and then increasing. Right, so let's type it in. Right, so start out with increasing on, this is the same as square root of 8, and here on here, and the decreasing there. Actually, this is the right one. Right, so we got that. Alright, then we're gonna have to look at the local max and local min. Here we know that here it's a increasing turned into decreasing, so you have here is the local maximum, and at this point it's not defined, so we don't have that, but here we know that it's a decreasing into increasing, so local minimum. Alright, so local max at the negative square root of 8 and local min at the positive square root of 8. Alright, so local max, which one was it? Local max first. Alright, local max at negative square root of 2 square root of 2. Local minimum at, so this is the one. Alright, so check the answer. We got that. Alright, then we have to take the derivative again. Alright, so let's look at that. Alright, another derivative, f double prime of x. Alright, derivative 1 is 0. Alright, so this is going to be negative. Let's see, I'm going to rewrite this, guys. So it's a negative 8x to the negative 2. Alright, if you take the derivative of that, put negative 2 in front, so negative 8 times 2 is 16. X, subtract 1 from the power, so it's negative 3. Right? So second derivative, 16 over x cubed. Right, so this one is pretty easy because, let's see, it's 0 is here. And if it's less than 1, less than 0, so it's going to be negative there. So you can see that if you try x equals negative 1, that will be negative. If you try a positive, it's going to be positive. Alright, so we know that, oops, this is a second derivative. So the original function is concave down up to 0, and after that, concave upward. Alright, so let's type that in. So concave, let's say downward on here, concave upward, oh actually the other way around. Let's see, concave down first, right? Concave downward here, concave upward on that, so this is it. So we got that. Right, inflection points. You can see that the only place that could have an inflection point there, but at 0 the function is not defined, so there is no inflection point. Right, so here is, whoops, there's no inflection point. Right, then we have a picture. So let's see, what was it? We have to do increasing, decreasing, decreasing, increasing. Right, increasing, nope, increasing, decreasing, decreasing, increasing. This is the one. This is not that. So this is the only one. So check the answer. We got that. Alright, that's it. I hope that this was clear.